Hi children, we are learning about basic properties of electric charges, and in my previous video we discussed about the two basic properties of electric charges, that is additive nature and the conservation of charges. Okay, now we are going to study about the quantization of charges, right? So the third basic property of the electric charge will be quantization of charges. Okay, quantization of charges, right? So now what do you mean by quantization, children? See, quantization means the physical quantity cannot vary continuously. Okay, the word quantization means cannot vary continuously but can take discrete values only. Okay, right? So what do you mean by quantization? The word quantization, right? So if I say that a physical quantity is being quantized, then it means that that physical quantity cannot vary continuously, but it can take only discrete set of values. Okay, right? Discrete values only, right? It can have only discrete values only. Now let's see what is this, right? Cannot vary continuously but can take discrete values. No, let's see what does that mean, right? So it says that if Q is the charge of any body, okay, Q is the charge of the body, then the charge of any body can be equal to, will be equal to integral multiple of the least amount of charge. Okay, right? The charge of any body or any system will be equal to the integral multiple of the least amount of charge. Okay, right? So E, what is E? E is the charge of the electron. Okay, right? E is the charge of the electron, or it will be the charge of a proton, right? So whatever it is, the magnitude of the charge of the electron and charge of the proton is going to be the same. That is, E value will be equal to 1.602, and it will go on into 10 to the power of minus 19 coulomb. Okay, right? So this is usually written as 1.6 into 10 to the power of minus 19 coulomb. Okay, right? So the value of E is 1.6 into 10 to the power of minus 19 coulomb. If it is a positive charge, then it will be plus 1.6 into 10 to the power of minus 19, and if it is a negative charge, then it will be minus 1.6 into 10 to the power of minus 19 coulomb. Okay, right? But when we consider only the magnitude, in most of the cases we will be considering only the magnitude. So in most of the places we will be just writing E is equal to 1.6 into 10 to the power of minus 19 coulomb, not minus of. Okay, right? So what is the charge of the body? Charge of the body is equal to the integral multiple of the least amount of charge. Okay, right? So this is what we mean by quantization. Okay, right? This is what we mean by the quantization. That is, we are expressing it in terms of the basic quantity of charge. Okay, right? Charge of an electron or charge of the proton is the basic quantity of charge. Okay, right? Or else we can say that this is the minimum amount of charge. Okay, right? So this minimum amount of charge by which the charge of the system is expressed is called as the quantum. Okay, right? So what is a quantum? What is a quantum? The basic unit. Okay, right? Basic unit or basic amount. Okay, amount by which the quantity can change. Okay, right? That's what I mean by a quantum. Okay, right? So now here E is the quantum here, right? Because the charge of the body is varying in terms of E only, right? So E is the quantum here. Okay, right? So now say for example, if I consider a body, okay, right? If I consider a body in which there are n1 number of electrons, okay, E minus, and n2 number of protons, okay, right? So E positive, okay, right? So if there is a system or a body in which there are n1 number of electrons and n2 number of protons, then the total charge of the body can be expressed as n1 into minus E, okay, plus n2 into plus E, okay. This can be, E is common here, right? So I can take E outside. So if I take E outside, what will I be getting, children? I will be getting n1 minus n1 plus n2, okay, or else I can write E into n2 minus n1, right? So again see, E into any number, right? n2 minus n1 will lead to any number, say for example n, right? So always, right? So always remember, charge of a body will be integral multiple of the least amount of charge, okay? This is what we mean by the quantization. Now what is the unit of charge, children? The unit of charge is coulomb, okay, right? Unit of charge is coulomb, or else I can just represent it with a capital C, okay, right? So hope you remember, if I write it in terms of coulomb, then I have to start with small c, or else I can just represent it as capital C, okay, right? So now let us define 1 coulomb, okay, right? We are going to define the unit of charge, or we can say that we are going to define the 1 coulomb, right? We are going to define 1 coulomb, right? So what are we going to do? We are going to define the unit of charge, or we can also say we are defining 1 coulomb, okay, right? For defining 1 coulomb, take the formula from 10th standard. We know that I is equal to Q by T, okay, right? So from this, what is Q is equal to? Q is equal to I into T, right? So if 1 ampere current, okay, if 1 ampere current passes for 1 second, okay, how much amount of charge will be flowing? That will be 1 coulomb, okay, right? So 1 coulomb is the amount of charge that flows through a wire for 1 second when the current is 1 ampere, okay. So this is the unit of charge, or this is the definition for 1 coulomb, okay, children, right? So now see, usually the value of 1 coulomb, right? Value 1 coulomb is actually a very high amount of charge. We usually go for smaller values only, okay. 1 coulomb is actually a very high amount of charge, okay. 1 coulomb is a very high amount of charge. Let's see, right, how many number of electrons will be there in 1 coulomb of charge, okay, right? So let's see that, then you will be understanding what I have written here, right? So what I'm saying that 1 coulomb is a very high amount of charge, okay, right? So now let us say that Q is equal to 1 coulomb, okay, right? So how many electrons will be there, or how many basic quantum of charge will be there? Q is equal to N into E. So N will be equal to Q by E, okay, right? Now what is the value for Q, children? Q is considered to be equal to 1 here, 1 coulomb. And what is the value of E? 1.6 into 10 to the power of minus 19, okay, right? So now when I divide these two, I will be getting the value to be equal to around 6 point, okay, I get the value to be around 6 point something, okay, right? So 6 point something into 10 to the power of 18, okay, 6.2, right? It will be around 6.2. So 6.2 into 10 to the power of 18, right? So 10 to the power of 18 is such a large number, right? So if I consider 1 coulomb of charge, then how many electrons are there? These many electrons are there, right? So that's why 1 coulomb is a very high amount of charge. We usually go for lower value of charges, that is 1 microcoulomb and 1 millicoulomb, okay, right? 1 microcoulomb and 1 millicoulomb, right? So 1 micro means how much, children? 1 into 10 to the power of minus 6 coulomb. Okay, right? 1 microcoulomb means 1 into 10 to the power of minus 6 coulomb, or else 1 millicoulomb will be equal to 1 into 10 to the power of minus 3 coulomb. Okay, right? So we usually go for microcoulomb and millicoulomb, not for 1 coulomb, right? Sometimes we will also go for 1 nanocoulomb, right? So 1 nanocoulomb means 1 into 10 to the power of minus 9 coulomb. Okay, right? So these are the values of charges that will be coming across, right? And sometimes we will also be coming across 1 coulomb for example. Okay, right? But remember, 1 coulomb is always a very large amount of value to be dealt with. Okay, right? So we don't go for 1 coulomb and all. We will be going for only the smaller unit of smaller values of the charges. Okay, children, right? So there are some places where we can ignore this quantization. Okay, so we can ignore quantization in macroscopic problems. Okay, right? So we can ignore the concept of quantization when we are talking about macroscopic problems. Okay, right? So see, macroscopic problem means what, children? The amount of charge will be very large. Okay, right? See, I will teach you this with a simple example. See, you are looking at a person who is standing at a very large distance away from you. Okay, right? So when you look at him or when you look at his hair, you will be able to see only a black shade. Okay, right? You will not be able to see the each strand of his hair, but you will be able to see only the dark shade. Okay, right? But so that is approaching a problem macroscopically, right? Okay, right? You are standing at a very large distance and you are looking at a person's hair, means it will be looking as a dark shade. So you are approaching him macroscopically. Okay, right? Now you go closer to him, right? When you go closer to him, and if you look at his hair, you will be able to see even the single strands of his hair. Okay, right? That means that you are approaching him microscopically. Okay, right? So when we go for macroscopic concepts, we can ignore the quantization concept, right? This I will tell you with an example. Hope you have understood that example. Okay, right? So see, I will teach you this with another one example. Consider a 60-watt bulb. Okay, consider a 60-watt bulb. Okay, children, right? So from the 60-watt bulb, how many electrons will be flowing means the number of electrons flowing per unit time. Okay, right? That will be equal, that works out to be equal to 2 into 10 to the power of 18 electrons. Okay, right? So 60-watt bulb is going to glow, means how many electrons per unit time are going to flow? 2 into 10 to the power of 18 electrons are going to flow, right? So this number again is a very large number when compared to the value of E, right? So you know that the value of E will be in terms of 1.6 into 10 to the power of minus 19 coulomb, right? So see, it is around 10 to the power of minus 19 and this is around 10 to the power of 18, right? The two extreme values. Okay, right? So when you take this concept, when you take the 60-watt bulb, it is macroscopic approach only, right? So in this concept, the value of E is very small when compared to N, right? The N value is very large when compared to the E value, right? So in all such places, we can ignore the quantization concept, right? So it's not an issue if we leave the quantization concept and we discuss these concepts, right? But when we approach microscopically, right? So microscopic level means okay, microscopic level means we will be handling only few tens or hundreds of charges. Okay, right? So when we talk about few hundreds or tens of charges, right, we say that we are approaching something microscopically, right? So only in these concepts we will be taking in quantization into a consideration. Okay, right? So these are the things which has been discussed in the quantization of charges. Okay, children, right? If you have any doubt, you can go through these notes, and if you have any doubt, you can ask me in the comment section. I'll explain it in my next video. Thank you, children. you.